Okay, so we fired up this Monsanto 3100A. We have the signal coming off of the back, and the top is off the front. That's 1 megahertz in sine wave, and the back is a rounded square wave 1 megahertz signal coming from the generator, or from the master oscillator. And we are reading right now a cold start, 1 megahertz to within about 0.54 hertz. So around half a hertz. As it warms up, I think it's going to get closer, so we're going to see. Well, we've been on about half an hour now, and we've warmed up a little bit, and we are now reading about, somewhere about we're reading about 0.11 to 0.13 hertz, somewhere in there, off. So we're about 0.11 hertz high right at the second. We'll check again in a few minutes. Well, the Monsanto has been on roughly an hour, and we are now running 999,999.9495 hertz. So we are 0.14 to 15 hertz off right now. So not quite 2/10. Not too shabby. Well, it's April 3rd at 4:30, and I just fired up the Monsanto 3100A, and we are getting right now 1 million cycles plus 1. So we're about 1 cycle over, and that's from a cold start. Now we're going to watch. I am pretty sure this thing is going to start decreasing. There's 1.09, and I'd say in about an hour I'll come back. We're going to check it again. Output looks nice. Bottom is the master oscillator. The top is the 1 megahertz output from the front panel. Check back later. Okay, it's 8:29. And we've been operating a couple of hours now, and the Monsanto 3100A is performing at, that's 1 megahertz to within 1/100th of a hertz. We're actually right at the limit of anything that I can measure anyway, because my rubidium source, that's about the best I've been able to get out of it as well. When she started out cold, she was a hertz off, so she's warmed up into this frequency, and she's holding. We'll check it again in a few minutes. In the meantime, I'm going to give you a good look at this thing. Right now, the output we have on the screen here. The top is the clock output coming out of the back of the unit. If we were to follow that cable back, you'd see it goes to the rear. And it's slightly squared off, which is just because it's a TTL clock. And the bottom is a sine wave 1 megahertz coming out of the front of the unit. That would be this wire, which we see wraps around the handle and comes into the front. We have an attenuator that is capable of going from a plus 20 to a minus 70 dB. We have a variable output attenuator as well for anything in between. We have a fixed output at 600 ohms, 5 dB into 600 right there. We can, as right now you can see, we have 1 megahertz to the 100th of a hertz on the display. So that's what we have chosen, and we are getting 1 megahertz to the 100th of a hertz right now. Well, that's beautiful. That would be mostly due to the new clock that has been installed in this unit. The major failure with the unit was that the clock had given up the ghost some time ago. I mean, if the unit is roughly 55 years old, so it's in beautiful condition. As you can see by the tear sheet in my ad, it has some spectacular specifications. Was a leading instrument in its time, ran several $1,000s at a time when people made that in a year. We have an input here that allows us to sweep the unit with a ramp. We have a recorder output. We can set our frequency using our selector switches on the top here, of which there are 8. Or we can put it into sweep mode with this switch. Sweep mode with that switch. And we can go either slow or fast, or manual or external with this particular switch. This is our sweep adjustment, and then this would be our decade select for the sweep speed. And as you can see on the display, we are in sweep mode. We are locked in to the frequency on top. I'm going to slow down the sweep speed a little bit so it's easier to see. Alright, it's not easy for me to see on this little display on the camera, but hopefully we can on the screen. The top signal is the TTL output of the master oscillator, the clock oscillator, and the bottom is the sweep out the front. And I can change that sweep speed from slow to fast. I can change the span of the sweep. Like right now I'm spanning roughly 10 hertz. This would be 100. This would be a 1,000 hertz sweep, 10,000 hertz sweep, and 100,000 hertz sweep. And we can go down to fractions of a hertz too. We can get right down to 1/100th of a hertz if we wanted. So, going back to front panel selectors, again we are locked in at 1 megahertz, and we're still displaying, we got within 200ths of a hertz, we have 1 megahertz right now on my counter, and that will likely change slightly as time goes on. Let's try dialing in a different frequency. Let's say we go 900 kilohertz, and we are displaying that on the counter right now. We have 899,999.98, so we're within 200ths of a hertz of being 900 kilohertz, which is what we selected on our front dial. Let's try 901 and see how we do here. That's about as close to, that's within 200ths of a hertz of being 901, right on the money. Let's try, so there's 901. Let's try 9011. There's 9011. We can change our resolution here and get a little better, little faster response. 9011, 90111, how about that? There we go. 90111. Make another one. So I can generate extremely accurate signals anywhere from about 100th of a hertz up to about 1.2 megahertz. So that would put me up through the AM dial and I could start out with low audio, from audio all the way through AM, making this a fairly nifty piece of bench equipment, especially if you're working on any filter design. You needed accurate signals. Let's take a look at the inside. We'll give you a tour. Access to the inside of the cabinet's relatively easy. It's a little 90-degree turn on these screws. The top springs up, pull her back, lift off, and we are inside. Very clean layout. There's all of our selector switches. All of the circuit boards are inside this nicely shielded enclosure. Cooling fan, power supply. And then this is our clock oscillator. And what I've done is, the oscillator, the original one was shot. I pulled all of the insides out. I purchased a new, smaller Vectron oscillator. It's the Vectron CO236T oscillator. And I was able to build a circuit board that I could fit right back into the original shielded unit. And if you want to adjust the frequency, you go through the original frequency adjustment hole as if this was an original unit, and you can adjust the frequency right through here. I'm not going to mess with it because it's already been adjusted and is accurate. It's a nice looking unit. Rack mountable, and I've also given it a nice set of feet. As you can see here. So programmability down to 100th of a hertz in resolution. Either a continuous output mode or a swept output mode with 1, 2, 3, 4, 5, 6, 7, 8 decades of sweep frequency selection. Sweep speed can happen slow or fast, and you can control the speed of the sweep with this vernier here. So all in all, very, very interesting and sophisticated unit. I'm going to give a look at the back here while we're at it. Yeah. Here we are at the back. We have the external standard in. You can put in an external oscillator and run the whole unit from it. There's a little switch right here that you go from internal to external. Here you can take the output of the internal standard and feed it out, as I am right now, to a scope or for another piece of equipment. You can amplitude modulate the signal that's in here through this particular port here. So you feed in your amplitude modulation and then turn this switch on. Okay, well, I've got the Monsanto hooked up to an audio generator. and I'm feeding it into the AM modulator input on the back panel here. You can see that back in here, but then what I'm doing is I'm going to modulate it, and I'm going to pick it up on this AM receiver. It's going to be a transmitter is what I'm going to be. Right now I am tuned on the AM channel to roughly about 1150 on the dial, so let's give that a go. And we can change the tone. So there we have an AM transmitter. There we have a view of the amplitude modulation. I can change the frequency on it and the amplitude. So there you have it. We know that that works. Well, I'm also demonstrating here that you can feed a ramp signal into this ramp input, and you can sweep the frequency. I'm going to change the voltage on the ramp generator, and you'll see me calm down up there. Then turn it back up again. I can adjust the frequency of the sweep. So we can see that that's working as well. Turn it down, turn it up. Change the frequency. So that's working also. It's a fine unit. Well, thank you for listening, and happy bidding.